Okay, so 12.5 is common and natural log. So what is a common log? What is a natural log? How does the graph look, etc. Yeah. So let's do it. Share desktop and Microsoft OneNote. All right. So Math 125. Is it there? All right. And then new one. So 12.5 is common logarithm, and natural logarithm. Common and natural logarithm. Okay. So what is the common log? So common log is a log with base 10. So if I write log x, okay, so log x, this is actually log base 10 of x. So if there is no base, then the base is 10. Okay. All right. So now, how does the graph look? Yeah. So let's talk about this. What is log base 10 of 1? Do you remember this? 0, yes. What is log base 10 of 10? 1. Do you remember this? What is log base 10 of 100? 2, right? Okay. So what is log base 10 of 0.1? -1? Yes. Do you guys remember how to do it or not? So this is like the question. 10 raised to what number yields or equals 10? So that is the question, and the answer is 1, right? Okay. Well, maybe I don't have to write it here. Yeah. So the answer is 1. And then here is 10 raised to what number equals 100? So the answer is 2. So when you graph this is really big, but you could still see the shape. Yeah. So if you graph this log, it's really big, but you could still see the shape. So if I'm graphing this log base 10, oops. So so this is really big. So 0, so 10, 20, 30, 40, 50, 60. Okay, see, I can't even graph it because it's too big. So let me do this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes. So 20, 40, 60, 80, 100. Yes. So your graph will still look like this. Log base 10 of 10 is 1. So this is 1 right here. Oh. Okay, and this is 2. So the scale is not equal. And then log base 10 of 100 is 2. So your graph still actually looks like this. Right? It's the same as the other ones. Oh. Something like this. Yeah, so this is 10, 1 and 100, 2. Yeah, let me make it a little bit better. Yeah. All right, so this is y is equal to log base 10 of x. Same thing. The graph looks like that. Same as any other log. Yeah. Now let's use let's use some calculators. So use calculator. Okay. So your calculator has log. Can you tell me what is number 1? What is log of 5? What is log 0.25? What is log, say, 125? Can you use your calculator? Very easy. So log of 5, that gives you what? 0.699? Yes. Good. What about log 0.25? Negative 0.602? Yes. What is log of 125? 2.097. Is that? Now, what about if I ask you what is log of negative 2.1? No. Why is it error, you think? Undefined, right? Why does it give you undefined? Look at the log graph. Does it cross the y-axis? No. So the domain of log is positive numbers. So let's write down here. So domain of log. Remember, the domain of log is 0 to infinity. It's positive number only. Yes. So negative 2.1 is not in the domain. All right. So that's what it is. Yeah. So it doesn't exist. Now, can you also use your calculator to calculate this? What is tan squared? Tan raised to the 2.1. What is tan raised to the negative 1.5? What is tan raised to the 0.25? So I think it's the same as the lock button. If you press second or something, do you see them on the same using the same button? Tan raised to the 2.1 is approximately what? 125.893. Yes. Tan raised to the negative 1.5 is 0.032 approximately. Do you guys follow with your no? Why don't you try it? Let me see. Yes, everybody should know how to calculate it. So what is your log? Log, okay. So you guys do log. Log. Log of what? So you click enter log of 5, and then you and then you log again. Log of and then calculate it. Okay, so this one, so you just going to do that, so you put it up. And then oh, you got it? Oh, I didn't know it. It's like this, yeah. What was 10 to the 0.25? What is it? 1 point what? 778? Okay, thank you. But anyway, you guys know how to use your calculator, right? Okay, now continue. Natural log. Yes. So next one is B, is natural log. So common log is log what base? 10, yes. Natural log, so first of all, let's talk about natural numbers. So E is a natural number. And E is irrational. Yeah, irrational. So E is a natural number and it's irrational. The value of E is approximately, you have your calculator. You have an E there. It's 2.71828, da, 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 da. Since it's an irrational number, the number never stops. The decimal never stops and never repeats, like pi. Irrational number like pi. So irrational number like pi, square root of 3, square root of 7. Those are all irrational numbers. Yeah. So the decimal never ever stops. So E is just a number between 2 and 3. All right. So how do you think the graph looks like? Well, it's going to be in between y equals to 2 to the x. Y equals to log base 2 of x and y equals to log base 3 of x. Yeah. Did we talk about E before? Yeah. So you know what E is? No? No? Okay. So now let's calculate using calculators. So E is called a natural number. I'm sorry. Let me let that. So ln x, this is log with base E of x. So when you think about E, think about 2.7. Yeah. So E, what is E? Approximately 2.7. What is pi? Approximately 3.14. So it's the same thing. What is E? Approximately 2.7. That's it. Yeah. So what is E? So don't be scared. It's just a number. It's just 2.7 approximately. What is pi? Approximately 3.14. Yeah. Yes. Oh yes. Yeah. You know Pi Day? Pi Day is March 14th. Yes. Yes. So people have to memorize those. Like my kids used to memorize those. Yes, yes, they do it, and then they have a competition. Yes. Right. Oh, my daughter was really good. She could memorize up to 200, like 196 or 197. Yeah, Arlene. Yeah, yeah. Oh, you know Arlene, right? Yeah, yeah, yeah. Arlene was pretty good. Yeah, before when she was in elementary school. Yeah, so I don't know how to do it. Like 3 numbers is good enough for me. 2.718, that's it, right? For me. But she practiced though. I mean, it's not just, yeah. So ln x, this is read as the natural log of x. So natural log of x. Yeah, it's log base E of x. Yeah, okay. Now let's use our calculator. So use calculator to calculate, to approximate. What is ln, for example, 5? What is ln 25? What is ln E cubed? Well, this one you don't need to use calculator. What is ln E? What is ln 0.1? All right. What is ln negative 2.2? All right, so let's just approximate. Well, this one is not approximate. This is exact. Okay. Now, what is ln 5? Let's try to use your calculator. ln 5, 1.609? Yes. ln 25, 3.219? Yeah. 3 decimals? Okay. Now, the next one is ln E cubed. Do I need calculator? No, this is just log base E of E cubed, which is 3. Yes, this is exact. This is using the cancellation property, remember? How about ln E? Log base E of E, that is equal to 1, yes. And then ln 0.1, well, that one we need to use calculator. ln 0.1 is negative 2.303. Yes. What about ln negative 2.2? What does your calculator say? Undefined. Why is it undefined? Yeah, so negative 2.2 is not on the domain. Yes. Yes. So how does the graph look? It's the same, what is it called? Oh, what did I just do? Oh, okay. It's the same, no, this is not what I want. So E, the rough sketch for all logs, the graph is always the same. It's going to look like this for all logs. Yeah. Any log with any base, the graph will look like this, and then this is 1. Okay. So the E looks like this also, so you see that negative numbers is not in the domain. Yeah, same shape. What about, can you use your calculator to calculate what is E squared? What is E to the negative 2? What is E to the 0.25, for example? So this is a calculator's job. So what is E squared? E squared is 7 point. Okay. Yes, whichever. Yes. E to the negative 2. What is E to the negative 2? 135. Yes. So E to the 0.25. 1.284. Yes. Doable? Okay. So next. We will use the change of base formula. I think Dr. K mentioned this already. He did, but I'll do it again. Yeah. Yeah. So C, is everybody okay with this? Okay, calculator is easy. So your calculator only has what? Log and ln. Yes. Yes, common log and natural log. Yeah. So see, this is very important and very useful. So it's called the change of base formula. So the goal is to use your calculator. So the change of base formula. Yes, here is the formula comes. Change of base formula. So suppose I have log base b of x. This is either you change it to log base 10, so log x divided by log b, or you could also write it as ln. So ln x divided by ln b. And this is very important. Why? Because you could use any base now. So for example, if you have log base 2 of 6, well, do I have log base 2 in my calculator? No, so we have to use ln 6 divided by ln 2 and then get an approximate value. All right? So what is ln 6? Remember to put the parentheses, divided by ln 2. And the answer, according to my calculator, is 2.585. Yes. Now, you could also do something really silly. I don't know. So, log base square root of 3 of 5.7. I know. I'm just making it up, right? I'm just having fun here. Okay. So, how would you write it? Well, it's just ln 5.7 divided by ln square root of 3. Okay. No, not nightmare. This is just a number. Okay, ln 5.7 divided by ln square root of 3. Yeah. Where is my square root here? Okay, here. ln square root of 3. All right. So 3.168? Oh. Yes, approximately, right? Okay, so you know how useful it is. It's very useful. Yes, Melissa? Both. Both exact and approximate. Yeah. Now, are we good with change of base formula and the logs? Because I'm done with 5 point. No, what is this? 11 point. Oh yeah. Today we have a branch in CDC, Child Development Center. Yeah, free branch. Oh, okay, good. Can you share it? No, in Child Development Center, they have annually they have a harvest branch. I think staff, you are invited. I don't know students. Are students invited? Yeah, you could just walk in there and then pretend you're a staff, right? You just say, "Oh, I work for the math department." That's it. Yeah. So yeah, it's today between 11 and 1. So if you want to come, it has to be today between 11 and 1. They serve pretty good food. Their turkey. Yeah. Yeah. So anyway, I am done with the change of base formula. Yeah. So we will continue with the next one, which is 5.6. I'm waiting for questions. Yes, Frank. Okay, let me help you with the calculator. Yeah, so let me help Frank really quick. So this is LN, which one? This one, right? LN6, so you're going to do LN6. Okay, so that's good. And then choose LN6 divided by, and then do it again. Just writing. This one, LN. Oh, I think you need to get a constant. Divided by LN2, or you can use mine. No, 34. So this is 2.5. 5.8. Okay. Oh, you just have to be quick. The other one is LN. LN 5.7 divided by LN 50. So you can do it. LN 5.7 divided by LN. So you just have to get LN squared off. And you go out. Okay, guys, let's start the next section. Okay, so let's save this in Math 125. All right, we're done. So it's very short. Okay. Now, what homework do you on Sunday? Up to 12.5, right? I think we might finish 12.6. Yes. Yeah. So 12.6. Okay, guys. This is exponential and log equation. Now, even if you never did any other homework from the previous section, you have to do this one. Yeah, this is important. So this is important. Yeah, exponential and log equation. Yeah. Yes, important. So the first one is exponential equations. So there are simple ones, but I think Dr. Kastner might have talked about these. But anyway, I will give you a little bit more. So so you guys don't get confused. Okay. There's my locker. All right. So so we have what is called principle of exponential equality. Huh? What happened? So principle of exponential equality. So if b sub x is b to the x is equal to b to the y. So x and y are exponent. Then what happened to x and y? They have to be equal. There is no other choice, right? If the bases are equal, then the exponent have to be equal also. So this is always true if b is not equal to 0 or is not equal to 1 or not equal to -1. So that is true. Yeah. Now, how do we use this? And also there is a principle of log equality. Oh, I write the principle wrong. How am I supposed to write it? PLE, yes. So principle, it's not the one we saw in high school, right? Principle of logarithmic equality. Yes. Equality. All right. Principle. So the way I wrote principle before was incorrect, so I just corrected it. So the other one is if x is equal to y, then log base b of x is equal to log base b of y. So we will use either of these principles, either principle of exponential equality or principle of log equality. Yeah. Now this one is easier to use. So this one right here is easier to use, but not always. Not can always be used. So for example, let's solve number 1. 4 raised to the 2x minus 2 is equal to 64. All right. Now I have to see first. Oh, let me wait for you first. I have to see first. Can I write both using base 4? Can I write 64 using base 4? Can I write them using the same base? Or not? Can we? Yes. So 64 is what? 4 cubed. Yes. All right. So then if we can, then what do we do? Well, they're the same base. What happened to the exponent? Yeah, they're equal. So 2x minus 1 is equal to 3. Well, then you could solve for x, right? So 2x is equal to 4. X is equal to 2. Yes. So this is easy, isn't it? Because you have the same base. Now, the next one is probably easy too, so we'll do a couple of easy ones. 3 to the x squared multiplied by 3 to the 2x is equal to 81. So I sort of have to use the law of exponent here. What happens if you multiply two numbers with the same base? What do you do to the exponent? You add them, yes. 3 raised to the x squared plus 2x, isn't it? So if you multiply two numbers with the same base, we add the exponents. Is equal to 81. Now my question is, can I write 81 and 3 using the same base? Yeah, which is what? 3 to the 4th? Okay. Good. Then what? Yes, so the bases are equal. So these two left and right are equal. The bases are equal. The exponent must be equal also. So x squared plus 2x is equal to 4. We can solve this, can we? X squared plus 2x Oh, I'm sorry. I made a mistake. When I copied this, is supposed to be 3x. Oh, yes. I made a lot of boo-boos today. Starting from the morning, where I forgot my charger. Okay. I'm sorry. Yes. X squared, but you guys always forgive me anyway, right? Okay, so minus 4 is equal to 0. Yes. Then you can solve this. What is this? X what? Plus 4. X minus 1 is equal to 0. So what is x? Negative 4 or x equals 1. All right. Good. Easy? Okay. So now, number 3. What about this? 5 to the negative 3x is equal to 1 over 6 to 5. So can I write them using the same base? What's the base? 5? Yes. So 5 to the negative 3x. Well, what about 6 to 5? It's 5 to the what? 5 to the what? 5 to the 5th? Negative 5? Is it true? To the 4, not 5. To the negative 4, right? Okay. Okay, good. So negative 3x is equal to negative 4. So what is x equal to? 4 over 3. Yes. Finish. All right. Are we okay so far? Okay. Good. Now, I'm waiting for questions. Nobody wants to give me questions? Nobody wants to ask? No, somebody has answer? No, nobody has questions, nobody has answers? Okay. All right, so number 4. What about if I have 2 to the x is equal to 15? Can I write 15 using 2 as a base? No, so this is where you have to use principle of log, equality. Yeah. So, well, look at this. How am I going to solve for x if it is on top? You have to bring it down. So how do you bring it down? We apply ln to both sides, right? So before applying ln, I need to make sure there is nothing in front of 2. I need to only have the base and the exponent. So just say if I have 3 here, 3 times 2 to the x, I have to divide both sides by 3. So what I'm going to do now, I'm going to apply ln both sides. Or log both sides. Log base 10 or log base e. I think ln is easier. So remember, what can we do if I have a log? Can I bring down the x? Yeah, so this is x ln 2 is equal to ln 15. Okay, now how do you solve for x? Well, that's easy. Just divide both sides by ln 2. Yes. So ln 2 cancel. Now this is called the exact answer. ln 15 over ln 2. So this is your exact answer. All right. Now can we get the approximate value? Now this is your calculator's job, right? So what is this? ln 15 divided by ln 2. Oh, I was opening my phone. I was going to use my calculator. Anyway, crazy day. ln 15 divided by ln 2 is, what is it? 3.907 approximately. So which answer do you need? Both. Yeah. I need both. Yeah. All right. So far so good? So you know when to use the principle of exponential and when to use the log equality? Yeah, so if you can write both using the same base, then use the principle of exponential equality. If you can't, then you have to use the log. Yeah. Now, what about if I have something like this? The next one, number 5. What about if I have 20 times e to the x is equal to 1,000. And then you also have number 6, 3 multiplied by 5 to the 2x plus 1 is equal to 15. Yes. What would you do first? So I have to write here, what do we do first? Divide by 20, yes. What's that? Maybe I have to put it a little bit up here. So you have to divide. You cannot have anything other than the base and the exponent. So only base and exponent before you apply ln. Yeah. So I cannot leave the 20 there. So what do we have? E to the x is equal to 50. Yes. All right. So how do I solve it now? Can I write e and 50 using the same base? No, so I need to bring down x. How do you bring down x? With the log of both sides. Log on the left, log on the right. Yes. So this is x ln e. So bring down the exponent. X times ln e is equal to ln 50. All right. Do we know what ln e is? What is ln e? Log base e of e. What is log base e of e? 1. Yes. So notice that ln e is 1. So ln e, remember, note ln e is log base e of e is equal to 1. So ln e is 1. Yeah, x times 1 is x. So x is ln 50, so this is your exact. Can you give me an approximate? What is it approximately? 3.992? Oh, 912, sorry. This is using calculator. Which one is required? Both. Yeah, so you need to use to be able to get the exact and use your calculator. Next, what do you think we will do here? We need to isolate, yes. We need to isolate 5 raised to the 2x plus 1. Can I write down? We need to isolate base and exponent. Before applying log. So here again, what do we need to do? Divide by 3, both sides. So here we isolate base and exponent. So I'm just going to write down base and exponent, and you know what I mean. Right? So we need to take out the 3 from here. So I only have the base and the exponent before applying log. Before applying ln or log. So 5 raised to the 2x plus 1 is equal to 5. Oh, actually, I don't need to apply the ln here, do I? No, because why? It's the same base. So what is it? 2x plus 1 is equal to 1. 2x is equal to 0. So x is equal to 0. Yes. Right, we don't have to apply log. Right? Do we? No, we don't. Yeah. Okay. Now, what about if you have something like this? 4 raised to the x plus 1 is equal to 5 to the x. Yes, Johnny, finally there's a question.
But rather than restricting the size, this could be like L and E.
Oh yeah, it will give you the same answer. So let's just say you don't recognize this. Then you're doing it the other way, right? So then you say, oh, I'm going to pick ln5, right? And then what would you do? Bring down the exponent, which is 2x plus 1 times, remember I need to put parentheses here, right? 2x plus 1 times ln5 is equal to ln5. Then what do you do here? Distribute to x ln5 plus ln5 is equal to ln5. Good. And then what do you do? You have to isolate the x, so what do you do here? Subtract ln5 both sides. So what is this? 2x ln5 is equal to 0. Then how do you solve for x? Well, same thing. Divide both sides by 2 ln5, right? What is 0 divided by ln5? So x is 0. Yeah. I think we should do more example on this, right? All right, so now number 7. When you're done, I'm sorry. Are you okay with this? Yeah, so number 7. So you're solving for x. What would you do here? Is 4 and 5 the same base? Can we write them as similar base? No. So what am I supposed to do right away? ln both sides. Yes. So then you will have x plus 1 ln 4. Okay, I'm missing something here. Yeah. I'm missing my parentheses. So x plus 1 times ln 4 is equal to x times ln 5. Yes. Yes? No? So what next? X ln 4 plus ln 4. So we distribute. X times ln 4 is x ln 4. 1 times ln 4 is ln 4 is equal to x ln 5. All right. Now we're solving for x. How many x's do we have? 2. So we have to make them on one side. Because I have 2 x's here. Right? So we have to make them on one side. So bring the x ln 4 to the other side, is it? So x ln 5 minus x ln 4. And here this is ln 4. All right. So I have 2 x's here. What am I supposed to do? Factor it out. So x times ln 5 minus ln 4 is equal to ln 4. Okay, so how do I solve for x? We will divide both sides by ln 5 minus ln 4. All right, so now I have my exact value, which is ln 4 divided by ln 5 minus ln 4. This is my exact value. Oh, I didn't box it yet, right? I box it after I find the approximate. Now, if you're using your calculator, make sure to put parentheses here. Yeah, if you use them on one shot. So what is x approximately? Yes, let me see. So ln 4 divided by, open parentheses, ln 5. Can each of you please try it? Because it might look easy, but then it's not. So 6.213? Okay. So this is approximate. Oh, you don't have to label it. It's just that I always do, so you know which one is exact. Exact is before we use calculator. Yeah. Is it doable? It's easy? Yeah. Can I continue with the log equations? This is exponential equations. Yeah. Okay, so let's continue with the log equations. Or just do one more, because we have 7 minutes. Do one more? Do one more like this? Okay, so let's do one more. Yeah. On exponential. So homework will be up to 12.5. Yeah, this is, I'm not done with 12.6, which is fine, right? Okay. Actually, we're on schedule. We might be able to have a test for chapter 13. 13? Yes, which is the conic section. Huh? We're on 12. We're going to be done by 12, and then we will do 13, and we can have a test chapter 13. Yeah, because we're good. We're on schedule. Yeah. All right. So anyway, number 8. What about if I have 5 times 3 raised to the 5x minus 2 is equal to 27? Yeah. So you think you want to do it first? Yeah. What would you do first? Very important. Divide both sides by 5. Yes. Okay. Can you please try it? So do I have any quizzes due? Oh, by the way, do you guys want me to open quizzes from the ones that I didn't open last time? Or just do it later? Maybe just do it later? Okay. Yeah. Okay. So no, not before Thanksgiving, right? You want to enjoy your Thanksgiving, correct? Okay, then I'll do it later. Whatever. Yeah. So like closer to the final, meaning to after Thanksgiving, I will open it? Okay. Then you have like 10 days to redo? Okay. Yeah, and before, so it's going to be before final. Yeah. All right, so let's do it. What do you do? Divide by 5. So we have 3 to the 5x minus 2. What is 27 divided by 5? Yes, 5.4. Good. All right, now, what do you think we'll do? ln both sides? Yes. So then, bring down the exponent. What do we have? 5x minus 2 ln 3. Okay, I made a mistake here. Parentheses, yes, remember. Yes. Is equal to ln 5.4. Yeah. Good. Now, what do I do next? Distribute, yes. So 5x ln 3 minus 2 ln 3 is equal to ln 5.4. All right. Now, I'm solving for x. How many x's do I have? Only one. So I just have to move this number to the other side, right? That's what I need to do. Because I only have one x, so I have to isolate my x. So 5x ln 3. Now, when I move this number, what will I have? ln 5.4, and this will be plus 2 ln 3. All right. Oh, yes, you can have 2 ln 3 plus ln 5.4. Yes. So Brandon's question was, can you write it as 2 ln 3 plus ln 5.4? Yes. Yeah. Good. So now how do I solve for x? Divide both sides by 5 ln 3, right? So x is equal to ln 5.4 plus 2 ln 3 divided by 5 ln 3. Yes. All right, this is exact. So what is my approximate? Now, if you use your calculator, you might want to put parentheses here if you're doing them all on one shot. Yeah. So what is this? ln 5.4 plus 2 ln 3, and then divided by, so remember to put parentheses, 5 ln 3. You have to put parentheses here too. You know why? You know why? Because otherwise you're going to divide by 5, and then when you're finished, you're dividing it again by ln 3. So that's why you have to put parentheses here also. Yeah. So divided by parentheses 5 ln 3. Parentheses, parentheses. So what is this? Yes. So 0.707. All right. Now we box this, and then we're done. Yeah. 0.707. Okay. Now, can I give you a quiz on Monday on no, 12.5, 12.6, the exponential? Can I just give you 2 problems on this? Okay, so why don't I write it Monday? Is that our quiz day on Monday or Wednesday? Monday is your quiz day, right? Monday quiz on 12.6 exponential equation. So you guys have to do well, okay? Now, do you think you could start on homework 12.6? I know it's not due, but why don't you start homework 12.6, okay? Yes. Okay, Adam, you can work on them during SI hours. Okay, you guys have a good weekend. Yeah, and have a plan for your Thanksgiving. Happy planning for Thanksgiving. Yeah. I have a dinner 2 dinners this weekend, Thanksgiving. Okay, guys, I will see you on Monday. Remember, we have a quiz, okay? And you start the homework. All right, this is such a fun class. Okay, we're done with common and natural log, and we started the solving exponential equation. So we're not done with logarithmic equations. Anybody needs to know thank you. Their grade? Oh, okay. Anyway. All right. Thank you, Giovanna. Okay, guys.